Welcome back. What we've done so far is we've looked at expansion or removing brackets. We've looked at factorization, putting things back into brackets. And now we tackle one of the uses of these two skills, dealing with fractions. Yes, fractions come to haunt us again, and we have to deal with the four operations of fractions. Let's get straight into it. Well, first of all, we're going to look at multiplying and dividing fractions. And here we have a worked solution. Just remember, with fractions, you have to factorize fractions fully first before further work. I'll say it again. Factorize fractions fully first before further work. So there's our first numerator, and they've factorized it. There's our denominator, and they've factorized it. There's our second numerator, and they've factorized it. And our last denominator, and they've factorized it. Now, because this is a division, what's going to happen? We're going to find the reciprocal. Reciprocal means top becomes bottom and bottom becomes top. Right, so here we're going to do the reciprocal, and here we go. Now, is this our final answer? Absolutely not. That factor and that factor can fly away. That factor and that factor can fly away. And have a look. X plus 2 and x plus 2 as a factor can also fly away. And oh my goodness, so can x plus 1 and x plus 1. What am I left with? I'm left with the answer of 1. Now, guys and girls, please remember, with fractions, you factorize fractions fully first before further work. And once you've done that, remember, only factors can fly. Just make fractions a whole lot easier. Let's go on to our next question. Here we're going to add and subtract. Now remember, back in the dark ages when you were in primary school and you had something like that, you had to have a lowest common denominator, and you multiplied things out to get, in this case, 3/4. What I'm trying to emphasize is that lowest common denominator. Now, in the example I used, I had a denominator of 4. Could I have used a denominator of 8, 400, or 12 million? Absolutely yes, I could have. Would it be the simplest form when I get my answer? No. Would it have been easy if I'd used 12 million as my denominator for a half plus a quarter? Absolutely not. That is why we try and use the lowest common denominator. Just makes life a whole lot easier. Let's have a look at the question. Well, here I have to add and subtract. Is that factorized? Not yet. Is that factorized? Not yet. So step 1, I have to factorize the numerator and the denominator. Factorize fractions fully first before further work. Well, there we go, our x plus 2 and our x minus 2, which came from our x squared plus 4. That middle term, the denominator is factorized, and there I have my x plus 2, x minus 2. Right, so what we've done is we've factorized our numerator and our denominator, and we have the lowest common denominator of x plus 2, x minus 2. Let's just double check that. That times something will give us that. That times something will give us that. And that times something will give us that. And it's the lowest form that we've got. Once again, we could have used anything as our denominator as long as it included the x plus 2 and the x minus 2. We could have had an x plus 3 or an x minus 7. Would it have been the lowest one? Absolutely not. Try and keep it simple. Lowest common denominator. Let's move on. So there we have our lowest common denominator, and we're going to write this as one fraction. There's our first term, there's our second term, and it's multiplied by our missing little bit out of our denominator, and there's our third term. We multiply things out, add like terms, and we land up with an answer. Is that our final answer? Well, can we factorize this slightly further? Yes, we can factorize it. Do any factors fly away? No. There's our final answer. I would give full credit for that or for that because there's no further simplification that can take place. Right, here we have a fraction, and we're going to show off our skills of factorization because we're going to factorize our fractions fully first before further work. And hitting straight in, I have a sum of perfect cubes. P first, second, first squared, first times second, second squared. Popping in my signs, plus, minus, plus. At the bottom, I've got a p squared. Let's look at our second term. Right, I can take out a 3 as a common factor, and I'm left with a p minus q. And at the bottom, I've got the difference of two squares, p plus q, p minus q. There we go. I have now factorized my fraction. Only factors can fly. That factor and that factor can fly away. That factor and that factor can fly away. Anything else? Nope. So, here we go. We write down everything else that's left. We've got a 3, we've got a p squared minus pq plus q squared, and at the bottom, we've got a p squared. Now, someone's going to say to me, can't this p squared over there and that p squared over there cancel? And I'm going to say to you, no, because they're not factors. The p squared on top is part of a bracket. Only factors can fly away. So we've got to leave it where it is. And that was our final answer. Back to screen. Here we go. That is our final answer. Let's do another one. Simplify the following. Well, once again, it's a fraction. So we have to factorize our fraction fully first before further work. Difference of two squares. P plus q, p minus q. That's our numerator. At the bottom, our denominator. I'm sure you don't mind if I reciprocate and factorize at the same time. There's our numerator that becomes our denominator because it was a divide. And at top, I can take out a common factor of p, and I'm left with p minus q. Well, what can fly away? That factor and that factor can fly away. That p and that p can fly away. And what am I left with? I'm left with a p minus q and a p minus q. Oh my goodness! A p minus q all squared. The best way of writing our answer. Just to reiterate, factorize fractions fully first before further work, and only factors can fly. Let's do another question. Well, this is a subtraction question, and I'll need to factorize that before I can sort out what my denominator is going to be. And it's the difference of two squares, a minus 7, a plus 7. Okay, what am I going to choose as my denominator? Well, a plus 7, a minus 7 includes both our factors. And actually, I call that my flower number because it's going to make fractions blooming easy. Here we go. A plus 7, a minus 7 as my denominator. What's the missing bit? A minus 7 over there. Is there anything missing over here? No. Some of you are going to say to me, why did you put it in a bracket? And I'm going to say, watch out for minuses. Beep, be careful. You're going to have to distribute those minuses. All right, so on top, we've got an a minus 7, minus a minus 7, and at the bottom, we've got an a plus 7, a minus 7, and moving across here, we'll have negative 14 over a plus 7, a minus 7. Can anything factorize and disappear? Absolutely not. So that's our final answer. Let's move on to our last question on this slide. Yes, we're going to have to factorize. 1 minus 2a on top, and we'll have a 2a minus 1, 2a plus 1 in our denominator. Ooh, perhaps we want to look at simplifying something there before we work out our difference in this question. Okay, here we'll have a 2a minus 1 and an a minus 1. That's our trinomial factorization. And on top, 2a minus 1. And the last little number doesn't need any factorization. Now, let's just have a look at this. A minus 1, 1 minus a. Very similar. And how about this over here? My 1 minus 2a and my 2a minus 1. Remember a little while ago, when we were doing factorization, we used switch around when it was a negative. I'm going to use switch around to help us simplify the question before we even get a denominator. Here we go. I'm going to write this as minus into 2a minus 1. And that's going to be over 2a minus 1, 2a plus 1. Here, nothing can help me, so I'm just going to have to carry on as is. But in my last term, if I make it positive outside, I can switch around inside. And have a look. That really helps us because that bracket and that bracket, as factors, are exactly the same. That one can kill off that one, just technically for the moment. So let's have a look at our common denominator. Well, we're going to have a 2a plus 1. We're going to have a 2a minus 1. And we're going to have an a minus 1. And there we have 3 factors as our common denominator. Right. Let's rig this up with our common denominator over here. Yes, this is a long question, and yes, you've got to be absolutely accurate. All right, what's missing over here? Well, in this case, our 2a minus 1 came back because of a denominator, and it's joined by a minus 1. In the next bracket, our 2a minus 1 is joined by a 2a plus 1. And in the last term, and I'm just going to have to write it over here, we're going to have a 2a plus 1 and a 2a minus 1. And that's going to fit in on the end. Right. Let's try and get this all done in one fell swoop. Negative into 2a squared minus 1a minus another 2a's gives me minus 3a plus 1. Minus into, oh, that's difference of 2 squares. 4a squared minus 1. And our last term, which was, and let's just double check, yes, it was a plus. That's also a difference of 2 squares, 4a squared minus 1. Now, Some of you will wonder why I've put the numerator in brackets. It's just to ensure that I distribute the negatives correctly. The negatives that I'm talking about, that one over there specifically, and that one over there specifically. Because if I didn't distribute them correctly, well, I wouldn't get the answer correct. So here we go. We're almost at the last step. Yes, this is a rather long question. Minus 2a squared plus 3a minus 1 minus 4a squared plus 1 plus 4a squared minus 1. Well, the 4a squared and the 4a squared can disappear. The plus 1 and the minus 1 can disappear. And what is my final answer going to land up being? Minus 2a squared plus 3a minus 1 over our 3-factor denominator. Sure, quite a question. And remember, once again, particularly with fractions, if you're accurate, you're great. If you're not, whoops, problem. Let's carry on. Here we have a couple of challenge questions. Now, challenge questions are not the everyday question. They've got a little bit of a twist to the tail. So read them carefully, and they're accessible. You've got the skills to do them. You just have to have a look and see if you can work out how. This one's fairly straightforward. We have to show that that can be simplified to that. So what I'm going to do is I'm going to start off with this little number over here, and I'm going to multiply it out and then refactorize it to get that. Well, starting with this, first squared, first times second times 2, second squared. First squared, first times second times 2, second squared. Tidying that up, 4x squared minus 4x plus 1 minus x squared plus 6x minus 9. Gathering like terms, 3x squared plus 2x minus 8. And I'm going to factorize that thing over there, and I'm going to get 3x and x, and I'm going to get minus 4 and plus 2. I've done it. There we had what we had to get, and here we've done it. Therefore, proved. Well done. Let's try another challenge question. What must be added to that over there to make it equal to this thing over here? Well, how about I multiply out this bracket first and see what I need to add? Well, first squared, first times second times 2, second squared. I could rewrite that as x squared minus x plus 4 plus 5x. So, what do I need to add to this to get that? I need to add my 5x. Answer, I need to add 5x. Now, guys and girls, on the surface, looking at that question straight away might seem incredibly difficult. But what skills did I use? I multiplied out a perfect square. First squared, first times, second times 2, second squared. You know how to do it. It's just knowing what to do when. The more you do, the easier it gets. Let's have a look at another challenge question. Evaluate that without using a calculator. Now, guys and girls, I've got to tell you, without using a calculator means if you anywhere show that you've used a calculator, can't give you any credit for the question. So, what is this going to involve? Let's have a look at the question and see if we can work out what's going on. Well, I notice that that is a perfect cube and so is 1. Sum of perfect cubes. How about I start by factorizing? Small bracket, first, second, first squared, first times second, second squared. Because it was a plus, plus, minus, plus. And what have I got at the bottom here? Oh my goodness, I've got a factor that can fly away. So what is my final answer? If I'm going to simplify this, it's x plus 1. Now, let's have a look back at the question. They told us that x was 7.85. So 7,85 plus 1 is equal to 8,85. We didn't need a calculator for that, did we? What did we need? What we needed was a working knowledge of factorization and fractions. Okay, that's what we have time for today. I hope that you've learnt a lot. Get out there and have some fun.